There we go.
Sheldon, we're live.
Hi there.
Hi, everybody, and welcome to another project podcast hosted by Next Generation Manufacturing Canada. I'm Jay Myers, CEO of NGen, and I'm joined today by Sheldon Fernandez, who's the CEO of Darwin AI. Darwin is a up-and-coming AI company based in Waterloo. And works on a number of initiatives along with NGen. I thought it'd be a really good opportunity to give you a bit of background about what Darwin is doing and an impression about where the world of AI is headed in advanced manufacturing. So glad to have you on board, Sheldon, and hope you don't mind if I start right away and just
Let's go.
ask
Thanks for
you a
having
little bit.
me.
Oh yeah, you're welcome. Tell me a little bit about, well, first of all, about yourself, Sheldon. How you got into the world of AI, and then also tell us a little bit about Darwin.
Absolutely. And Jay, again, thanks for having me. Great to be here. In a story of, well, myself and Darwin AI is interesting. So I went to the University of Waterloo many, many years ago, graduated, and then started a software consulting company with a number of classmates. And we actually began life on Wall Street, writing trading systems for very large banks. Lehman Brothers was our first client. So we often joke we outlived our first client. It was around 2017 that we were acquired by a much larger company called Avanade. They're co-owned by Microsoft and Accenture. And that was also the time that like the second wave of artificial intelligence characterized by machine learning really began to develop outside academic circles. And I took note of it for a number of reasons. It's always been an interest of mine and so forth. So as we were getting acquired, a former colleague of mine introduced me to this academic team at the University of Waterloo, spearheaded by Professor Alexander Wong, who's Canada's research chair in artificial intelligence. And they had created some really groundbreaking IP around machine learning and deep learning. And I just found myself reading their papers and increasingly being interested in it. And I wasn't planning on starting another venture. I mean, we just exited, our first venture after about 16 or 17 years. And I was going to not retire, but I was going to take some time off and drive my wife to work and, watch hockey and eat Tim Hortons. But I was just drawn to this team and what they had done. And lo and behold, 3 months after exiting my first venture, I agreed to run, Darwin AI. And we went through the Creative Destruction Lab program in Toronto, which I would highly recommend for budding entrepreneurs. And, we decided to commercialize this technology and went through a number of iterations and pivots, which I'm sure we'll talk about, to arrive at the place we're now, which is applying AI to advanced manufacturing kind of applications. The interesting final note I'll make is 4 months after, getting our seed round of funding, my wife got pregnant with our first child. So for the past 5 years, I've really had two startups. I've had an artificial intelligence startup called Darwin AI and a biological intelligence startup called Max Fernandez. And they're both magical and exhausting in equal measure.
That's great, Sheldon. I imagine you're enjoying one much more than the other.
It depends on the day, Jay. It depends on the day. But
yeah,
yes.
yeah, exactly. So, look, lots of interest in AI, and particularly applications in manufacturing. Lots of interest in machine learning. How would you define AI in that context? And I people often refer to AI, but not necessarily with maybe with an on the ground practical sense of what this technology is.
Yeah, it's such a great question. I often refer back to Professor Ajay Agrawal's book called Prediction Machines, and he's one of the founders of the Creative Destruction Lab, where I thought his way of describing it was very simple. And he said, if you look at what AI does exceptionally well right now, it predicts things with a certain probability, right? It'll give it a picture and it'll tell you this is a picture of a lion or cat with unerring precision compared to a human being. And so where machine learning really took things to the next level was really doing very powerful prediction of image data initially and now other types of data. And so when we think about that in the context of manufacturing, well, what is the benefit when I'm doing a very complex manufacturing process to be able to look at a set of variables, an image of something, sound, other data, and really do high quality prediction around a given circumstance. And we certainly saw the potential of applying artificial intelligence to that realm, which is why it's so exciting. So if like that's the way I would conceptualize artificial intelligence in very straightforward terms. There's a lot of the popular media you'll hear with Chat GPT and so forth, but even then, you're giving it a question and it's formulating a response based on the probability that it thinks that response will resonate with you and that it's delivering the information you want. So that's the explosion we've seen in the past 4 or 5 years with machine learning and deep learning that has made all these wonderful things possible, certainly in manufacturing and in other domains as well.
So if AI is a very powerful tool system of prediction, I guess one thing that manufacturers should be keeping in mind, or any company using this, is where in your process would a better system of prediction help you achieve your business objectives?
Absolutely, right. And I would always start with two qualifiers. One is, do I have data for the given scenario that I want to predict? Because as many of us know, AI systems require data to learn on. And two, is there a concrete outcome where increased prediction would benefit my business, right? And so, for example, there's very difficult prediction that machine learning systems are not good at. The one I often come to is a bunch of machine learning scientists and academics got together, Jay, about maybe 3 or 4 months ago and tried to predict the winner of the World Cup. And it's very difficult to do that because of all the different variables that affect the outcome of a sporting event, right? The players, the referees, the weather, like it's almost impossible to predict it with perfect precision. However, can I predict the way a protein will unfold? Well, yes, because I have a lot of data and I have a lot of mathematical reason to believe a certain prediction is correct, and I can verify it.
Right.
And so that's the question to hone in on. Where in my whole business process would increased precision around prediction be a business benefit to me and one that I can measure?
Right. And of course, a lot of that depends on the quality of data that you're using. So you've worked with a lot of companies, Sheldon. What are some of the issues that, for any company looking to apply AI, that they have to think about in terms of data quality or data readiness, really?
Yeah, the first question is, do you have the data or do you have a means of accessing or obtaining the data? Right? We started working with manufacturers maybe a year ago, and half of them had the data, but they didn't have it in an organized and coherent format conducive to building an AI system. And so for the first 4 to 6 months, you're working with them to just build data and build data sets. For the others, they didn't even have like the hardware or the images to get quality enough data for the process. And that's why, and I'm sure we'll get to this, we actually had to build a hardware offering so that manufacturers would have a system that would capture the data at a high enough quality for artificial intelligence.
Right.
So those are the two things I would think about when you're thinking about an initial project. Do I have data, and is it quality data?
Well, tell us a little bit about some of the what Darwin has been up to, and maybe your journey as a company. And I know that that's taken you off in some weird and wonderful directions in terms of some NGen work that you've undertaken with Aspire. But tell us a little bit about that journey.
Yeah, it's an interesting journey. So when we started Darwin, our vision was to build a platform using our proprietary technology that other data scientists and other AI developers could use to develop very trustworthy and robust models. For example, one of the challenges you'll often hear with AI is what people refer to as the black box problem, which is that the AI can do all these wonderful things, but even the designers of the system don't really know why it's reaching the decisions it reaches. And so we have proprietary technology that illuminates that black box and will give you really quality reasoning as to why things are working that way. We were doing okay with that approach. And then in March of 2020, of course, the world turned upside down and really prompted a rethink on our side of where we thought the commercial potential was. A couple things happened in sequence that resulted in our current pivot. So number one, in end of March, my team, using our technology along with researchers at the University of Waterloo, about 10 days between the time when Ontario shut down the province because of COVID, they developed an AI, which we called COVIDNet, that diagnosed corona based on chest x-rays and CT scans, and did so with about 94% accuracy with very little data. And we open sourced it. It didn't seem right as an organization to benefit when the world was on fire. So we open sourced it. We gave it to the community. And the response from the community was, this is great. And they started leveraging it in geographies we would never have imagined: China, the US, London, Malaysia, Australia. But then the second reaction was, how did you do this so quickly? And that's where we realized that the commercial potential of what we had may have actually been applying it to vertical problems instead of this horizontal platform. So that was the first thing. The second thing that happened, and Jay, you know about this, is we got involved in a very ambitious, very inventive project with Aspire Food Group based in London, where they had the vision, of course, of building a protein production facility centered around crickets. And it was fascinating in its own right. But what amazed us was the way we could apply deep learning to really benefit some of their needs around increasing protein yield and so forth in their facility. And that's when we realized that we needed to really go vertical, and that manufacturing, in fact, was so exciting because it was the foundation for so many other industries to build different things, to build a world of, my son's going to inherit one day. So that's when we decided, based on those two experiences, that manufacturing really was interesting to us. And then within manufacturing, we said, okay, well, what are we going to do? Where in manufacturing are we going to play? And electronics manufacturing, for a number of reasons, excuse me, was very attractive to us because of the movement of a lot of sensitive electronics manufacturing work back to North America. And so the area we focused on was the production of PCBs, or printed circuit boards, that go in everything from your microwave to your toaster to your car. We now have brought a product to market that visually inspects these and really makes North America competitive when it comes to manufacturing them. So very interesting way to arrive at our current destination, and in part thanks to NGen, because of the aspirations around the Aspire project, which, of course, I have to mention, got an award from a research body of realizing the UN sustainability goals, and it was named one of the top 10 outstanding projects for 2021, one of two in North America, the other being NASA. So it was quite nice to get that distinction.
Yeah, congratulations on that. That is, it's quite a distinction, Sheldon. But we were mentioning Aspire, and we've had Mohammed on our podcast before from Aspire, talking about his great vision around high quality protein based in his facility in London. But maybe before we jump into the electronics application, tell us exactly what Darwin's role was in the Aspire project, and how it helped Mohammed and the Aspire team reach their objectives.
Yeah, and it's a wonderful story. I mean, I met Mohammed I was in 2020, before any talk of collaborating, was real. And it's one of those meetings where you've met a special individual, and at some point you're going to work together, but you don't know the context in which that's going to happen. And of course, when his idea came a little more to fruition of mining, and growing these crickets for protein purposes, the part that he needed was the digitization of that entire process. Sheldon, we're generating so much data that we don't even know what to do with it, but we know that we want to optimize our outputs for that data. And we want to basically use as much environmental input as we can to ensure that we're maximizing cricket yield and learning things about the process that we otherwise wouldn't have learned. So our job was to basically bring the brain of that whole digitization process to fruition using our artificial intelligence. And so we look at things like, the humidity in the facility, the various quantity of crickets in different bins, their acoustics and the noise they're making is significant. And we basically, using all that data, try to come up with predictive analytics around how do you maximize, your cricket yield, and what are the fluctuations you can make in real time that'll result in, that maximization. And what else can you learn after the fact about your processes to improve it moving forward? And what was interesting to us was that we were very good at dealing with inanimate objects, right? A picture of a wrench, a picture of glass. Crickets, of course, are living organisms, and AI needs a lot of data. Well, in order to detect, for example, a malnourished cricket or a sick cricket, you need data of that. You don't always have it with a living organism. And so one of the challenges we were faced with is how do you manufacture negative data, as we call it, for living organisms? You can do it with a part, you can scratch it. You don't want to hurt a living organism. And so that's where our ability to, create what's called synthetic data, which is, it looks like a real cricket, but it's not. That was very, key in a part of this system. So that's essentially what we did for Aspire, and are currently doing for Aspire. We're still engaged on the project. But I think it was really an illustration to my team that we didn't have to live only at the technology level. We could branch out into the physical real world, and that could actually be more exciting than just the abstract world of data and code. And so it's an important element in our transformation, Jay.
Well, and I think, as you say, Sheldon, too, the having to deal with living organisms and developing the synthetic data application there is taking a long way on the tech side as well. It's not just a simple application. There's a ton of research and innovation that you're going through as a result of that project.
Correct. Yeah, and one of the buzzwords you'll hear now in AI is generative AI, which is AI generating things. And ChatGPT, of course, is the popular manifestation of that. We leverage that technology to generate data for different, permutations of faults and so forth that we'll need to see. So it very much resulted, you're right, not just in upwards the stack and, developing applications, but on the foundational IP side of getting my team and academics to think in creative ways about what we had to do at the AI level to deal with living organisms, and then eventually some of the other manufacturing areas that we forayed into.
And now you're applying the solution that you've developed and you're learning to electronics and particularly to quality control around PCBs. So tell us a little bit more about that application.
Yeah, so of course, printed circuit boards, those little green boards that you see, are again in everything from microwaves to toasters. I think my wife just bought a kettle that has them. And that was how I was able to explain to her the significance of what we're doing. And there's a very standard but complex process for producing them, for manufacturing them, right? On the printed circuit board, of course, you have semiconductors, you have all these different electrical components that in a very intricate way have to be arranged to realize the functionality of the PCB. The gap that we found in the marketplace was the end of the process is still very manual. There's still a human being that is picking up this PCB and looking at it to ensure a certain level of quality. And there are numerous gaps, I should say, in the industry as a result of that process. One, it's manual, it's people. And the challenge we're seeing is that labor force is retiring, and that there's not a new labor force that wants to do that work. And part of that is related to the pandemic, but part of that's just, challenge.
And a huge turnover too, because this is
yes.
One of the least interesting visual inspection, one of the least interesting jobs that you could ever imagine.
Absolutely. Of course, we're seeing a lot of the movement of this work from different parts of the world back to North America because of global concerns, China, Taiwan, the war, and so forth. So there is this pressure for manufacturers to do some of this work back in North America, and Canada has a real opportunity here. And then, of course, this industry, the electrification of everything, is growing at about 15% per year. So we saw those factors and said, we have a real opportunity here. And so the part of the geometry and so forth, you need advanced artificial intelligence to do this competently. And so that's what we developed. And we brought a product to market maybe 4 months ago that does this visual inspection. And about 2 weeks ago, we were at the Apex conference in San Diego, which is the conference in North America for this type of thing. And the reaction was overwhelmingly positive. I mean, people were looking at it and they would have to pause because of how quickly we could do this inspection and how quickly we could configure new products in our product line. And so it's early days, right? I don't want to get ahead of myself, but the initial signaling is very strong, and we're just very excited to be a part of this transformation.
And I've had the pleasure of coming in and seeing how this system works. So tell us a little bit about how it works, but also the savings that it generates for a company.
Absolutely. So you have, if you can picture it, maybe a box that is maybe 2 or 3 times the size of a standard microwave, and it fits into the line where these PCBs are being produced. And as the PCB goes in, we do a very quick analysis using artificial intelligence. You have a screen that's a very intuitive user interface, and we can explain why the AI is doing what it's doing. Now, one of the magical moments that we often get is the big challenge in this industry is configuring new boards, right? A board for an elevator looks very different than a board for a car. And so how do you configure the system to recognize flaws? The old way of doing this, and this is what you need to do with incumbent systems, is somebody who's trained needs to go in and configure every single part, like 300 parts, which can take them days, sometimes weeks. And so many of these systems, they're called AOI systems, are ineffective as a result. With us, you give us what's called a golden board. That's a board that you know is flawless. We use AI, we understand it, and away you go. When we were in San Diego, I explained this process to 3 people that between them had about 100 years of experience in the PCB industries. And one of the more cynical gentlemen said, you know, Sheldon, we've been hearing this for 20 years. I don't want to ruin your party, but I'll believe it when I see it. He said it at breakfast. And I said, I understand. Come by our system tomorrow, because this was the day before the show. So they came, and when we showed it to them, and we showed different products, and it wasn't pre-programming, that was the aha moment. Mm-hmm. And he stopped and he said, you've created the iPhone for PCB manufacturing, meaning it's so simple and so obvious. And that was the moment that got him. So that's the setup, and that's the advantage of the system. Now, in terms of the benefits, why would a company do this other than, you know, the cachet? You're doing things faster because AI is faster than human beings. Cameras are faster than eyeballs. You're doing them more accurately, and you're detecting flaws earlier in the process, which leads to diagnosing the problem ahead of time and results in less rework. So reduction in, you know, scrap, more product that you can develop in a, you know, reduced amount of time, and overall savings around just operating expense. Those are the first order benefits. That's the very simple back of the napkin calculation when they say, how much does your system cost? What are the benefits? Okay, it's going to take a month and a half for me to get a year's worth of payback. Very easy. But we're also learning about the second order benefits, which is you're collecting so much data every time a PCB runs through the process. What is the benefit of that? Well, they're starting to think about this now because we're showing them the art of the possible. Can I use this for a more holistic analysis of line efficiency? What lines are more efficient than others? What plants are more efficient than others? What other things can I capture with the amount of data I'm collecting? And that's just a part of what we're exploring with some of our, you know, initial clients, is the art of the possible around that.
No, that's very good. It just builds on the idea that you've got possible constraints throughout your process, throughout your enterprise. But if you can analyze the problems in one link, you've got a pretty good view right across the entire network there. So what's in store? Where are you guys going? Not only with the technology, but with the business?
Yeah, so, you know, we did a fundraise just before the holidays, which was nice to get done with BDC's Deep Tech Fund. And like I said, we brought the product to market maybe 4 months ago. We have our first OEM client. The system's going live in production this month. And then we have a big EMS clients. These are clients that, you know, make these for other clients. They make them for the Apples, and they make them for the, you know, Samsungs and so forth. They're our target market. So we have our first 2 clients, and it's really just to, you know, kind of penetrate into this market and become the standard for the area we're playing at. So that's a very simple year for us, which is, really get and service these clients. That there's probably about a half dozen that, we want to do in the next, I'd say 4 to 6 months, and then probably a dozen thereafter, and really enable this. But I think what really excites us is what are the possibilities once we are starting to collect this amount of data that we can enable beyond just our current product. And so we have a very ambitious roadmap around what we call digitization for the PCB industry and ushering in, the factory of the future, because when they see what you can do in this realm, their thoughts immediately go to, well, what other things can I do if I brought artificial intelligence visual inspection to other parts of my business?
Right.
So that is kind of our more, forward-looking kind of ambition, is to enable this in general for visual inspection. Right now, we're very much focused on this particular area, just given the opportunity in front of us.
Right. I think the benefits of simplicity, of a very easily usable and manageable solution, really comes forward when when you take a look at your solution here in electronics. It's not to implement that is pretty straightforward for any company.
Yeah, I remember a board member made a distinction to me once, and I play it in my head every now and then. There is a difference between a hard problem to solve and a valuable problem. And they often overlap, right? But make sure you're focusing on valuable problems that are simple, as you say, Jay, to implement.
Yeah.
And so, you need to come to an enterprise with a system that they can understand and that is straightforward and doesn't have a lot of overhead. Start simple is what I tell entrepreneurs that are trying to do the same thing we are, and then you can get more ambitious with interconnecting systems and all that.
So let's back up a little bit and maybe broaden the discussion, Sheldon, to
Sure.
Maybe some best practices in terms of companies looking at implementing AI. What would you say are some of the key lessons that you've learned, or that through your use cases that you would point to for other companies, including manufacturers, looking at implementing AI?
Yeah, great question. I would say start simple. So start with a use case that is straightforward, that you have data for, and use that as the example to illustrate the benefits of AI, and that will usually result in organizational buy-in. Where I've seen enterprises trip up sometimes is they have these huge, grandiose ambitions that are overwhelming for the people involved, and they don't really get off the ground, right? I mean, in the heyday, we saw these very well-funded innovation labs and all these kind of experimental parts of the company. And I rarely saw those translate into concrete business benefit. So start simple. Like, what is a problem where if we added a little bit of visual inspection or some AI element, there would be a benefit? And, I can get it off the ground quickly and it's straightforward. I can measure it. Then once you do that, a couple things happen. Number one, the organization starts to wrap their heads around AI and what it means, right? Your data practices, the governance you'll need around the data, the systems you'll need, all those things will start to develop in the context of a project like this. And then people will see a win on the board, right? And then that'll lead to more serious contemplation around other areas of the business you can start to do work. So start simple, use that as a beachhead for a grander digital transformation.
That makes a lot of sense. I get the impression sometimes when companies are looking at implementing AI or even implementing data strategies and data readiness and improving their data, maybe not so much pushback from the people who are actually, using the technology from a higher management level. Well, why would we do that? We're doing it fine the way that we're doing it today here. And is that a fairly general type of pushback that you see, or is it is this just me kind of responding to a few criticisms of what we're trying to do.
No, I think it is real, right? You are all whenever you're disrupting the status quo, you will get pushback. I mean, we're humans; it's human nature. I think the key is, first of all, learning about their business and their workflow, right? We actually had to go to the factories, sit with them, understand what they're doing to speak their language. And when we speak to manufacturers, we don't speak about AI and explainability. We speak about escape rates. We speak in the language that they understand and resonates.
Right.
And so that's a very real thing. And I think it begins with understanding them, but also letting them know, look, AI, like all things, is a tool. Like just as there's a camera on the thing that's taking pictures, so you don't have to do it, this is going to analyze it for you. And so getting them over that concern that, we're not here to replace you, we're here to augment a system. And where AI excels, where machines excel, is that rote, repetitive work that you frankly find boring. And so this will free you to do more creative, strategic things, and things that still a machine can't do. That we have some purchase with. So understanding their world is very important, and then how you position the solution and what it does as augmenting human beings and ultimately trying to help you, I think is very key.
And I think too, just helping companies identify the value that they have in the data, what they can do with the data. Everybody's collecting data from so many sources, but what data is important? What is high quality data versus data that really is not meaningful, is not valuable at the end of the day? Is connecting it to the business outcome is so important, as you said.
And we've been fortunate. Our CTO has quite a bit of background with medical imaging, so he was able to point to a lot of analogous use cases in radiology and so forth, where they didn't know what to do with the data, but they kept a lot of it, and then after the fact, they would analyze it and come to certain business outcomes that they never contemplated at first. So you're absolutely right, Jay. Like serving a problem here and now is certainly important, but getting them to understand that every time they have an instance of something being inspected or something go through the system, that's an opportunity to learn. And so we may not know exactly what the value is yet, but let's capture it anyways. Let's put it somewhere, let's store it, archive it, and then we can go back to it with fresh eyes and see if there's anything valuable there. Yeah.
So I can't let you go without asking the key question about skills, young people, qualified people who are qualified to work on either with you at Darwin or maybe in the implementation itself in manufacturing. What are you seeing right now and as I always point out, sort of as companies need to automate, some of the skill shortages are going to become even more acute. On the other hand, AI is a pretty good solution for some of those, and automation, pretty good solution for some of the skill shortages we're seeing. What are you seeing, Sheldon?
From like the students and younger audience, so to speak?
Yeah, or just the whole issue of skill shortages. Do we have a pipeline of young people do you see coming into the area of AI and automation, and maybe particularly interested in the manufacturing application side of things?
So on the AI side, absolutely, right? I mean, it is the computer science of the 1990s, because that's when I grew up, where you can almost envision young ambitious parents telling their children, hey, if you want to hit it big, go into AI, because that's going to be the next thing. That's probably, my son is 4, but it's probably what I'll tell him in a few years. So certainly, I mean, Professor Alexander Wong, our chief scientist and Canada's research chair in AI, I mean, his undergraduate courses are just filled to the brim with young, ambitious people, students who see this as the next thing. On the manufacturing side, we have some work to do to convince the younger generation that this is an industry that is worth investing in. And I think back to a chance meeting I had with our prime minister and the German chancellor, maybe 6 months ago, is the German Economic Club, when the German chancellor visited, and he was asked about how do we get young people excited in mining and manufacturing, and I'll never forget his answer, which really got me thinking, which is you have to frame it as this industry is what is going to be the foundation for creating all the materials and everything we will need for the next economy, for the next number of industries. I mean, if you want to innovate in physics or in medical devices, somebody's got to make those. Who makes those? It's an advanced manufacturing process. And so I know when I frame it in that way, and this is what excites us, of we're creating we're innovating and disrupting the base industry that realizes all these other industries. That's really where I get the excitement. And so we're starting to see that now, right? Of you want the factory of the future, you want the next wave of materials that's going to do X. Guess what? It starts with building this stuff. And so I think there's real opportunity for us who are in manufacturing to frame it in those terms that make it compelling.
Yeah, and making stuff to solve the big challenges of the world, like environmental sustainability.
Yeah, and we haven't talked about this.
What a great recognition for you.
Yeah. Sorry, Jay, you're getting me excited. There's an ESG element to this as well, right? If I eliminate waste and I make things more efficient and I use less water and electricity, now, for example, there's a huge output to that. I was on a panel with last year with the head of Honeywell's sustainability initiatives, and 43% of carbon emissions happen with industrial buildings, not the buildings we live in. And he just talked about, a little bit of movement of the needle in making things more efficient, like 2 or 3%. He showed the effect that would have on the environment, and it was profound. And so the environmental implications of making things faster, quicker, less wasteful are significant. And I think we're going to see that, that part of the story become a little more pronounced in the years to come.
Great. Thanks, Sheldon. So for anybody who wants to follow up with Sheldon, what's the best way to connect with Darwin?
Yeah, they can email me directly at sheldon@darwinai.ca. We're, of course, on Twitter and our LinkedIn page. We're always looking to connect with interested folks. Happy to do that. And of course, Jay, I have you to thank and NGen to thank for kind of steering us in this direction 2 years ago. So, we look forward to advancing advanced manufacturing in Canada, as it were.
Yeah, that's great. I always like to remind our project partners, and I've said this many times to Sheldon, where we think of ourselves a bit like a wet T-shirt. We stick with you.
Definitely, I can vouch for that.
We help you fund the project, but we also help you succeed. So really glad to have you in our group, Sheldon, and all the best.
Thank you very much.
Cheers. Thanks.